Good evening, everyone.
Good evening, sir.
Thanks for responding, Benika. Good evening, everyone.
Good evening, sir.
Thank you, Adrian. What about the other students in the class? Are you here or you're just logged in? Is it just Asia and Benika in class tonight?
Night, sir. Evening, sir.
All right. Let me not go my best to get the good evening. And I'll just begin. All right. So I trust that today finds you very well, and that you're in that frame of mind for work. And I had given you 2 handouts to read. How many of you read it? Okay. So let me start again.
Good evening, sir.
Good evening, Mikey. I gave you guys 2 handouts. How many of you had to read through the handouts?
I read through the handouts.
Sir, I read through the handout.
Thank you. Thank you, Adrian. Thank you. Thank you.
Yes, sir.
Thank you. What about the rest of the class? Is this how unresponsive you guys are? No, I need to know. Because I have a strategy to deal with those students who are unresponsive in my class. Is this how you guys are? Oh yeah. Oh, talk to the students. Hello, students. I don't want Mikey, Vanika, and Asia to answer me, please. The rest of you, good evening.
Good evening, sir.
You Jesus, may I beg it? All right. I don't want to hear from Asia. I don't want to hear from Mikey. I don't want to hear from Vanika. I need somebody to tell me what it is that they read through the handout. Let us go through the handout for me, please. And please all don't rush me at once. So the rest of you are away from Asia, Mikey, and Vanika. I need somebody to unmute and tell me what it is that they understood from the handout that you read, or the handouts. Okay, let me do this another way. Daniela, can you unmute for me, please? Delia, can you unmute for me, please? Denicia, can you unmute for me, please?
Hello, sir.
All right. Now, this is what I'm going to do. I am not going to be going through this tonight. I'm very serious. Right now, my system is kind of boiling. I'm going to give you an opportunity to speak to me. And those of you who are not speaking, I'm going to put you in the waiting room. And I'm serious about it. If when I call upon you and you're not responding to me, I'm going to put you into that waiting room. Davia, please to unmute. Okay, and then she decides to just get out of the class because she's not unmuting. Fine, no problem. Janelle, can you unmute for me, please? This is
Yes,
crazy.
sir.
Did you read the handout?
I don't have access to the handout.
Why not?
I don't think I downloaded the file and it was sent on WhatsApp, right?
You don't think you downloaded the file? What was my instruction for class last week?
To read the handout in
Okay.
preparation to class.
Okay, so you got the message then, but you didn't do it. Okay. Daniela, can you unmute for me, please? Wait for the second time, and if I ask you to call up me again, Daniela, you're not here, I'm going to put you in the waiting room. Daniela, can you unmute for me, please? Okay. This is crazy. It's really crazy. I can't believe this. This is crazy. Davey, I called upon you. You heard when I called upon you, you exit the class and you're back now. Can you unmute me, please? All right. Oh, we'll come up here a second time. Denicia, can you unmute for me, please?
Good evening, sir.
Did you read the handout?
No, sir.
Why?
Sir, I was supposed to read it the day that you sent it, but I reached home very late and then I forgot. Sorry.
Okay. Kylo, unmute for me, please.
Hi, sir.
Did you read the handout?
Sir, honestly, today is probably my second class, I believe.
Did you get the handout?
No, sir.
Leonie,
Good night, sir.
good night. Did you read the handout?
Sir, no, and I'm not in the group.
Okay. So what are you going to do about that?
So I'm gonna join the group now.
Okay. Thank you. I'm not in a bad mood here, guys. I just don't like lazy students. I'm not in a bad mood. I just don't like lazy students. And this is just unacceptable. Carol, good night. Can you unmute for me, please?
Good night, sir. Good night.
Did you read the handouts that I sent to you last week, Wednesday?
The handouts?
Yes, ma'am.
Wait, so you can remind me of the handout again?
Okay, all right, never mind. You can mute. Let me just stop and tell you something. Let me just stop and tell you something. As I said before, I'm really not in a bad mood. Tonight is one of my most relaxed days. I took the time out to just sit down and just relax and just prepare for you guys. I was waiting for 7 o'clock to come from about 7 this morning. Right. Today has been a very good day. But I don't like lazy students. I do not like lazy students. This now explains. I normally teach in the associate degree program, but I normally teach pre-calculus. This now explains in clear tones those C's that I'm seeing. Some of you are barely surviving, hang up on piece of thread. Hang up on piece of thread. Because you're not reading. You are not reading. And you come to class and you're depending on what the lecturer gives and you're moving with the lecturer. So if you come to class and I talk foolishness, you can't read it on your own. It's unacceptable. It's unacceptable. I'm getting your grades and I'm looking at it and say, oh my goodness, then can't get some B's and some A's, why all of these are C's? But I don't understand. It's totally unacceptable. Totally unacceptable. And because of that, I'm going to send reading for you. I'm going to kill you with reading. And I'm serious about it. If it means that I have to do this in order to get you to get the information into your head, I'm going to do it. You can't depend on me to come to class and give you the information. Remember, I know I studied this enough. I know this. And I want to impart the knowledge to you guys. And I cannot come to class. Did you read the handout? Oh no, sorry, this is the handout. When my instructions were, I'm going to see if I can join the class at 5 because I have this thing to do. When 5 o'clock came, I was nowhere near the. I said, guys, read the plan. No, read the plan. Just read the stuff for me, please. Wednesday, Thursday, Friday, Saturday, Sunday. That's almost 5 days. Not almost. It would have been 5 days because the class was 5 to 7. So exactly 5 days. And people are coming to class to say, but they tell me, say, boy, sir, I read it, and I don't remember what I read now. It's a different story than, sir, I didn't read it. Don't worry about it. Because starting now, my readings that I'm going to be sending to the class will attract a percentage to your final grade. So you don't read, it's not a problem. You just don't get that grade. There is no way you can be doing earth sciences. There's no way you can be a scientist and not read to get the views of others and put them together and say, oh, this don't make no sense and that makes sense. You're just depending on what me come to class and tell you. Okay, so what I'm going to come to class and tell you is an overview. Now I'm going to give you an overview. And then now ask you to do the full view for me. Come on, students, this is unacceptable. It really is unacceptable. No, man. Can't work. Oh my goodness. Came to class in a fabulous mood. And then your behavior just kind of just turn it, man. Jesus. If you don't want to do the work, you know, it is going to be to your detriment if you don't want to do the work, you know. All right. All right. I'm really very disappointed. I really am very disappointed. And if you're not in a WhatsApp group, I'm going to ask you to put your information in the chat so that my very able assistant will add it to the group. I'm not even accepting that as an excuse. That, sir, I'm not in the group. I'm not accepting it. I'm not accepting it. I'm not accepting it. All right. So as I said, if you think that I'm going to come to class and give you the full 100, no, you're going to read for it. I'm going to give you an overview to whet your appetite, and you're going to be reading. There's no way on earth you can be doing stuff and don't get the information. It is frustrating. It is frustrating. I cannot conceive. I cannot conceive. No, imagine me go and I found somebody fabulous handouts and I say, yeah, they have a robust conversation, and I don't know why I asked if anybody read it. So better me never ask the question. It can't work. So I'm going to be giving a percentage for these handouts that I'm going to be flooding you guys with. Don't read it. And it means that geology is going to be a course that you have to resit. Don't read it. You can't wait on my information to go into the exam and just belch back what I tell you on the paper and you don't even research it on your own. I had a student last Monday in a private conversation, sir, I'm ready for the presentation. Sir, you know much textbook never go read just to get the information. That is the spirit. I ask you to do something. I want you to go and read it and internalize it and understand it so that when you give it me on paper, you can explain what is happening. Don't give me what somebody said. What is your explanation? What you understand from it? Okay. Let's go. All right. Does anybody know or heard about the Big Bang Theory? Anything you hear about it? It is even one sentence you hear about. What is this Big Bang Theory?
Sir. All right. Well, you have two Big Bang Theory out there, so you have to be specific. You have the TV one that is scientific, and you have the scientific one that is not TV. So the scientific one that is not TV, sir. All right. So it's basically states that at the beginning of time, there was a catastrophic event that had the birth of the universe. So from that, the universe was a single point, and from that explosion, you had different elements that were out there that started the expansion, the birth of the universe.
Okay. All right. So in a nutshell, that's what it is. Anybody else? Thank you very much, sir. Anybody else? And we're going to come back to version 1, version 2, which of them we're talking about, okay? By the way, which version he gave me a while ago?
The version 1.
The version 1, okay. What is the version 2?
It's basically a debate between creationism and the Big Bang Theory.
All right. Okay. All right. So we're going there. All right. Thank you for at least you know, understand where you're reading up. But the mere fact that you're calling the terms suggests to me that you're reading. Okay, very good. And we're going to come back to those. Anybody else?
Sir, that the earth was once, or the universe was once like compressed, and then there was a huge explosion that created the planets and all the other the stars and whatnot.
Okay. All right. Pretty much that's what the Big Bang Theory is talking about. It's really how astronomers explain the way the universe began. It's really how astronomers explain how the universe began. And it is really just an idea that, as both of you say, that the universe was just this single point, right? And then expanded or stretched to grow as large as it is now. Do you believe that it is still stretching? Yes or no?
Yes.
Yes, sir.
Okay, it is still stretching. Very good. Yeah, man.
According to Neil deGrasse Tyson.
Okay, so him say it's still stretching.
Yeah, he said there is evidence that it's still expanding.
All right, very good. Now, so again, this sort of idea stems from what it is that I was saying to you, that the geology of Jamaica compared to the geology of Hispaniola, Cuba, Puerto Rico, and these other Caribbean islands, the ABC islands, you know, et cetera, there are similarities in the geology within this particular hemisphere, you know, and, you know, we spoke about other stuff earlier on, and we recognize that there are several theories out there to say that we were all one continent, and then we something catastrophic happened, you know, catastrophism coming out of that, where it is that we have this breakaway of different continents, and the geology of each of these islands is supporting that theory. It's a theory that I believe in. I believe that theory, and I'm going to tell you why I believe the theory. Because it's just like your fingerprint. It's unique. And this is just I talking now. Jamaica has a very good groundwater reserve. Excellent groundwater reserve. And when we drill down to our piezometric levels, we can literally drink from the groundwater. This is how pure the groundwater is. And you know one of the reasons why the groundwater is this pure? It is believed because of our
topography.
True, but also our limestone deposits, right? Our limestone deposits is believed to have this sort of attenuating property of pulling impurities from the water. So our groundwater reserve is crystal clear, good something to drink, good something to use as potable water. When compared to other countries where you literally pour water from the tap and you can see organisms running through the water, right? So when you hear they talk about Jamaica, land of wood and water, it's not now make up, crazy slang that they want. It is really our geology that it is, right? Now, when you look at our limestone deposits, it coincides with other deposits in our neighboring territories, suggesting that, you know, we were part of, which is what this whole Big Bang theory is talking about. That it started off with one little toops, you know, just one single point. It could be a catastrophic event that caused this explosion, and it fragmented into many different things, right? Now, when we spoke of during your presentation, there are some names that came up, and those names are very important because those researchers did quite a bit of fundamental study, you know, in coming up with these ideas and these theories that we are looking in, and we are currently studying. Now, it's very developing because we have physicists and chemists and biologists and astronomers and you name it, who are trying to prove and disprove some of these theories. So one such astronomer, who is Georges Lemaitre had a big idea. Lemaitre said that for a very long time, the universe started as just one diggy single point. He had this very strong belief, a very strong belief. You notice, you know, I said 1927. Earth, I mean, creation was long before then. Long before then. Yesterday, in one of my little things just to reflect, I sat in a chair and grabbed fun story. It is as a result of the graduation that I was guest speaker for last Wednesday, and I still believe that I should have just not go there and stay at my class, or else what happened to me wouldn't have happened. And they sang a song, and I stood up and I started singing the song. And then my guest said to me, "You have the words?" I said, "No, but funny enough, I'm remembering the song." And I don't remember the title of the song, but I just started singing, and it took me back to my primary years of education. It took me right back to my primary years. And while I was singing and looking around, I looked into the audience and I saw a parent who herself did not have the words of the song in front of her, but she was singing. To the point when I went up and I started speaking, I called her out. I had to call her out because it brought back a whole lot of memories. So yesterday, I grabbed someone's hymnal and I started just going through the songs. And I said, wow, this brings back a whole lot of memory. And when I look, what's the point? When I look at some of these stuff, 19, let me see if I can grab it and tell you what it is, because I still have borrowed books with me. I reach up to hymn number 20, so before. It says Susan Warner, who wrote the song "Jesus Gives Us Shine with a Pure, Clear Light," Latin the candle burning night. She was born in 1819 and died in 1885. Right? If I come to Jesus, he will make me glad. He will give me pleasure when my heart is sad. That song was written by Francis and Alstein, and that was written in he was born in 1820 and 1950. The point I'm making, Georges Lemaitre was born in 1927, right? So you have people who were living long before he came up with this idea that the universe started with just one single point. He, however, said that the universe stretched and expanded to get it as big as it is now. And he theorizes that it keeps on stretching. Now, Mikey, you made mention of, when I asked the question, you said that yes, it is still stretching. Why do you believe that there's still stretching of the universe taking place? What evidence do you think you can point to suggest that it is being stretched?
Okay, sir. All right. So based on what I've read, they have markers in terms of stars.
Very good.
And they have a measurement from Earth to that particular star.
Very good.
And in recent times, majority of these are the distance have widened, and some of them are now out of reach where they are able to see and measure those distances. So it suggested some expansion.
Very good, very good, very good, very good. Some reading that I was doing also spoke about the stretching of these galaxies cause the clumping, a galaxy stretching in such a way that it bounces into another galaxy and then it fuses to that one and form a bigger one or something new that is produced. Yes, ma'am, you are correct. So the distance between these galaxies are increasing, stars and you name it. And it is evidence enough to say that some levels of stretching is still taking place. All right? So the universe is really a big place, a huge place, and it has been around for a very long time. If one was to think about it, it would be very, very, very hard to imagine. Very hard to imagine. One of the other names that we need to talk about is Edwin Hubble, right? Just 2 years ago, or 2 years later, from when Lemaitre did this stuff, an astronomer named Edwin Hubble noticed that other galaxies were moving away from us. The
Sir,
farthest, go ahead for me, not hearing me?
sir, he was the one that the Hubble telescope was named after?
Absolutely.
Okay.
Absolutely, absolutely. And you know, it's one of the things that I want us to get from the get-go. You see, when you hear the names of these places and objects and instruments, they are named after people who did their initial invention. Like the, oh Lord, what is it called now? Like the Crawl River in Clarendon. There is an exposure in Clarendon that is called Crawl, right? So when we're referring to that exposure, we call it Crawl. And I was wondering what is in the name. So when I went, you were talking about Crawl River, I was like, people crawl by the river? Why Crawl River? Why have such a name as Crawl River? It is because of the exposure. So there is something in the name. Don't just hear the name, something like that, and then just say, oh, it's just by accident. No, man. So the farthest galaxies were moving faster than the ones close to us. The farthest galaxies were moving closer than the ones closer to us. And immediately there, it points me, I don't know how many of you did chemistry, but forgive me, I'm going to go into a little bit of chemistry class. It says that the farthest galaxies were moving faster than the ones close to us. It makes perfect sense because right there and then I'm thinking of an atom with its orbitals. And if you can go back to even your third form chemistry, where you have this atom with many orbitals or shells or energy levels, as we call them, you have those outer ones who are very energized, you know, especially if it is not a stable, it is not a noble gas, for example, argon and neon, that has its outer shell filled, you know, maximum 8, then it becomes very active. If you think of sodium, for argument's sake, that has an electronic configuration of 2,8,1. The first shell of sodium has 2 electrons and the second shell has 8. The last shell has 1. So that last shell with that 1 electron, I'm going to run up and down because guess what? I'm looking for a mate. That one is so ready to go ahead and give up in order to become ionized, so that, you know, in can just say, boy, you're the plan, I have to lose no more energy. And chlorine, for argument's sake, with electronic configuration 2,8,7, chlorine has 7 electrons in its outer shell. And chlorine says, here the plan, the amount of energy is going to take from me to give up them 7 electrons. I better just take one from somebody. And sodium says, hey, come here, brethren. Yeah, man. And you're so nice. So chlorine and sodium form such a nice bond to the point where it has a giant ionic structure. So I'm thinking about it to say that, and incidentally, let me finish my thought. And incidentally, the electrons that are in closer to the nucleus are unreactive. It's just the valence electrons. So when I say to you that the farthest galaxies are moving faster than the ones close up, you can understand why. You can understand why. Because, you know, the inner electrons will take part in the chemical reaction. It's just the outer electrons. And that's why we have these energy levels. The amount of energy it will take for me to move into one of the other shells, past the outer shell, it will destroy the atom. Put it that way. The atom will be destroyed. All right? So the farthest galaxies were moving much faster than the ones that were close up. So this meant that the galaxies are still expanding. Just like the Dmitri thought, if things were moving apart, it meant that long ago everything had to be closer together. So it means that they were so close and that the farthest ones are moving in with lightning speed, suggesting that the theory that it was one little spot, a little point, and something catastrophic happened. We don't know. Something catastrophic happened. And they have a breakaway now of these of this now, fragmenting stuff. And one fragment gone this way and the other fragment gone this way, but they are still existing and orbiting and moving in such a way, but, because of this sort of stretch, the amount of energies that exist, it's moving farther and farther from its original source. So yes, you are correct. The distance measured between these galaxies are expanding. Then, sir, people really go up, they're going to read. They have instruments and gadgets that they can use to theorize things that are happening. Funny story, just to show you that these gadgets work. A couple of years ago, when you're going to school, and maybe you can tell me, you guys are now in university, because though we're a community college, we're still offering a university degree. So yes, you guys are in university. If I were to ask, how many of you have a regular dental appointment, meaning it is so structured? Just tell me no. Anybody have a structured dental appointment that every 6 months you go to the dentist? You don't have to make it up. You can just tell me yes or no. It doesn't mean
No,
that, right?
No, sir.
no, sir.
No, Mikey. My answer to you would have been no. When you go to university, dentist, you brush my teeth and I floss. I don't need to go to the dentist. I just never needed to go to the dentist. And then when I started working, the dentist if there was a problem. No, there was a problem once because I love prunes and I started, cracking the nut in the prune, and then the next thing I heard creak. And when I heard a creak, I put my tongue around here to see what was happening, and then my tongue split in two. And I was like, okay, am I gonna bleed today? And long and short is that I went to the dentist following day, and I said, okay, sorry, we have to shave all the tooth. We have to put a crown here now because of what has happened. And I was like, oh crap. No, look how good me have all of my teeth them in my mouth. And because of this one something that I love, caused that to happen. And then I said, okay, fine. And then I started having at that point in time, if I were to confess, it was at that point in time, I then developed a regime to go to the dentist. And one such visit, the dentist says to me, sir, I did an x-ray and I'm seeing something that I am going to be watching. I said, okay, fine. I said, what is it? And then she showed me something and I said, of course, you first make you see that to me. Because the man with the naked eye wouldn't see it. Never paid it any mind. The following year, because I think you do that, the x-ray like once a year. The following year, did the x-ray of the motor again, and she said, sir, you remember I told you that? I said, yes, you did. She said, well, I am a little concerned now because, and then she showed me the x-ray from the year before to this one. I was like, oh, yeah, man, I see. No, it's visible. But all of this is happening inside the tooth. No, when you look at the tooth, there's nothing wrong with the tooth. I said, okay, fine. And then she said, all right, I'm going to watch it. I said, all right, no problem. Then the third year came around, and she said, no, we have to get in because something is happening. And I said, but she said something getting in. And when I went and did the procedure, something was there for true. Something was there. Don't know what trauma I would have experienced earlier, but something was happening on the inside of the tooth. So on the outside of the tooth, you're not seeing anything. Sometimes you woke up in a wall and you play sport and a man kick the ball in your face and you don't know what going on and thing, and years later it will start to develop. I don't know what trauma I experienced, right? And of course, they had to remedy the situation in order for it not to get to the nerve, because that could cause infection and radiate so forth. What's the point I'm making? There are technologies out there now that never happened before when we were going to little school. But there are technologies here now that they can do an X-ray and they can actually test the health, your oral health. So I'm telling you, there are instruments that the man can sit on Earth yourself and look up into the galaxies and say exactly what's going on. So I'm saying to you, don't disbelieve that they can actually have a guesstimate of a measure, right? So what the dentist did was to look at something and she said, okay, I'm guesstimated to be this length, right? Couldn't tell me exactly how long it was, but when she compared that event with the event the following year, she recognized that the second event is much larger than the first. And then now she compare the third event to say, no, for sure, it has quadrupled or tripled or fourpled the first event, but it is definitely larger than the second event. And guess what? I can't wait until the next year because my patient now is going to come now with an infection, maybe a gum disease and whatever the situation is. So I have to now take corrective measures. That's exactly how these astronomers are doing. They will go and they will get a rough estimate and they will calculate it. They will get an idea as to the distance between these galaxies. And then at a given period, they may look at it and say, hey, hold on. Didn't we calculate it to be such and such centimeters? Come here, look at what is happening now. It was 5 centimeters the other day. It is clearly 6.5. Okay. And then the mathematicians around them will say, when was the last time you checked it? They say, well, it was exactly a year ago. Okay, 365. So 365, and it increased by 1.5. So the man we have a theory now to say every revolution, complete revolution, they can say that there is a movement of 1.5 centimeters. So just like what the dentist says to me, and I don't know if you're seeing the analogy that I'm making, just like what the dentist said to me now, the following year or the following period, they are going to be looking at it again. And if the following year they recognize that it was 5 and it now gone to 8, they say, hold on. But last year it was 6.5 and it gone to 8 now. What is the difference? Jesus, is the same 1.5. So in the initial year, it moved to 1.5, which took it to 6.5. Then it moved to another 1.5, which took it to 8. So can we therefore say no that every year, every 365, it moves by 1.5 centimeters? So this is how these astronomers get information. And Limerick would have done a lot of stuff and able now to see exactly what is happening and have some empirical data. Are you seeing the comparison and the relation to see how it is that they can get the measurement to say that it is still stretching? Yeah, no?
Yes, sir. Yes, sir.
All right. So everything we see in our universe today, stars, the planets, the comets, asteroids, they weren't there at the beginning. They never did it at the start of it. And then somebody troublesome will say, then sir, if they weren't there, where them come from? Interesting. Anybody have an idea where they come from? They weren't there in the first place. Because I'm saying to you that it was one little spot. Something catastrophic happened. And then now we're talking about asteroids, comets, planets, stars. Where them come from? Any suggestions? Any ideas?
Sir. All right. So after the explosion, the Big Bang, there was high temperatures, and as cooling occurred, you had the formation of protons, neutrons, different elements, which then fused to form what we are seeing at present.
Excellent. Excellent. How did you get that information, Mikey?
Read it, sir.
Okay, I'm sorry. I thought you were born with it. So you read it. Very good. I was just trying to say that so that the non-readers in the class can feel back. Very, very, very good. So it is a fusing of these. I see what I did earlier. I spoke about the atom. It is a breaking away of these stuff and the fusing of these other atoms coming together now to form these new stuff. All right. Now, at some point in time today, because I'm going to finish this thought in class tonight, and I'm seeing that there's 56 minutes left, and I'm going to finish it in 56 minutes. And there are 2 other things that we need to look at. Mikey spoke about which of them? He's correct when he spoke of them, but we're going to talk about 3 things. The first one I chose to talk about tonight is the Big Bang. So when the universe began, it was hot. Tiny particles mixed with light and energy, right? It was nothing like what we see now. And so everything expanded and took up more space and it cooled down. Now, it is in this cooling that these tiny particles group together. One of the things you'll know about temperature is that it increases the rate of a reaction. It increases the rate of a reaction. Try mixing some little sugar and water, just call it lemonade, in cold water. And you stir, and you stir, and you stir, and you look at the bottom of the something, and a pure sugar crystals is on it.
Sugar would have never melt.
It not melt because it's cold. All right? So therefore, when it tastes, it's fresh. And you throw more sugar in there, and you throw some sugar in, and some sugar crystals will dissolve, but you're going to end up with more sugar crystals at the bottom of the stove. All right? If you take just 1 teaspoon of sugar and put it in some warm water, what do you think happens? Do you have to stir it?
No, sir. Dissolve quickly.
No,
sir.
You don't have to. Veronica, Mikey, yeah, you don't have to stir nothing. If you, and incidentally, don't put no sugar in your tea here. We need to cut down the amount of sugar that we put in our bodies. All right? But if back then, if yesterday when you made your tea, and we know going forward not putting any sugar in our tea, if yesterday when you made your tea, and you said, sure, y'all, I'm gonna put the tea bag in the cup with the teaspoon of sugar, and then the kettle boil and you throw the water on it and you never remember to stir it. I'm going to tell you, you're going to have diffusion in the liquid itself, that the sugar crystals at the bottom of that cup is going to be moving to evenly spread itself out, and through the water. So you don't have to stir it, none at all. You don't have to stir it. So when you have and surface area also increases the reaction. So there are several things that increases the rate of a chemical reaction, right? Surface area is one, temperature is another one. So this temperature causes these tiny particles to mix with light and energy. So it break it up because of this heat. Break it up. And then as it cools now, you're going to have one tiny particle grouping with another particle, a new compound is formed. Grouping with a different particle. So you may have one molecule of something grouping with a piece of something. And you have the same molecule, a piece of the same molecule of something grouping with another thing. You have two different compounds that are being formed. All right? So these tiny particles are grouped together, and guess what? They form atoms. Jeez, let me tell you something. You see, when you look at the atomic structure, good, bad. So those of you who would have done chemistry, in third form, one of the first things that chemistry teachers will say to students, you must know the first 20 elements of the periodic table. So you can't leave third form without knowing the first 20 elements of the periodic table. Up to fifth form, you're supposed to know the first 20 elements of the periodic table. You're supposed to be able to form structures, make and break bonds, etc., etc. But when you move on to sixth form, you have to know the next 10 elements, which are called the transition elements, right? Sometimes we go out into the field and we see these brightly colored minerals. Wow, they are transition elements. Beautifully laid out. One of our pastimes, catch me any day of the week and I'll do it. And when I went to the conference, not last week, the other time when I went and I was trying to connect to class and couldn't connect, went to that conference. One morning I got up early, had breakfast, and I just needed to clear my mind. I had so many things on my mind. I just needed to clear my mind, and I just walked along the shore. I walked along, and I just looked at God's beauty, and I said to myself, wow. And then I looked down and I'm seeing these exposures and I'm saying, wow. I said, even though the place is very nice, look at what it is that we have done. we have disturbed the natural habitat because we go out and we drench the sea and take out the sand out of it to come make nice seashore so people can come sunbathe. And then we go and build groins into the ocean. So 20 meters out, people can just walk ankle length or waist length out into the ocean. We're disturbing the natural habitat. We're disturbing the natural habitat. We're disobedient. And if you go to some other hotels, they build this island into the ocean where people can just walk out and sit out into the ocean, literally sit in the ocean and just sunbathe. And some of them have weddings and them something out there. We have disturbed the ocean. We have disturbed God's natural plan for us. And then I looked down and I saw a lovely limestone rock. A fragment of it, that is. There was a bigger portion and then a little piece. But the little piece was so rectangular in shape, I bent and I picked it up and I said, this is coming back to Kingston with me. And I looked at it and I tried to look at some of the mineralogy inside of it and I was like, wow. And we're going to get to I'm going to come back to that story now because a little later on we're going to talk about some mineralogies, right? And I looked at it and I was like, wow, just look at what is happening. But that in itself took a long time to create. It is not something that is overnight. It took a long time to create. And when you look inside of it, you will find a composite of different minerals fused together to give you something that is very strong, not necessarily a sandstone. And because of some catastrophic event earlier in our geological past, we may have an intrusion that now brings up an igneous exposure, which is even stronger. All right. So, and then you will see more minerals coming out from within the Earth's crust. All right. So when these particles come together, they form atoms. And these atoms now are alive. They have protons, they have neutrons, and electrons, and they have a mass number. They have, of course, there's a weight in it because you know, the periodic table is so arranged according to weight. And you'll find out that you will have the gases existing on top. Then you have the liquids existing in the middle. And then you have the solids existing beneath. So when you look at the halogens, chlorine, bromine, iodine, bromine, you have astatine. Astatine is a solid, but bromine is a liquid, right? But guess what? When you move to the upper level, you can recognize that beneath bedrock, you're going to have a layer of liquid existing under there. Sir, or you're going to have liquid existing under bedrock. It's just the beauty of how this formation, it is inexplicable. So in one sense, you can say to them, say, boy, you can't have a liquid existing under a solid. All right, even a gas. But in another phenomenon, you're going to see something like this happening. One may say, sir, it is because of plate tectonics. You have the movements of these plates now, and then you're going to have liquid getting in between these crevices of these plates. So these plates are now sitting on top of each other. It's not a perfect fit anymore. So where there are gaps now, where these plates have moved, you have water filling those areas. And then you say, whoa, this is where now it takes one to explain the whole geology of it. And for you to understand the whole chemistry behind what is happening. And some of them we can't explain. Some of them, they're just beyond you, you can't explain. You know it exists. You know it's there, but you can't explain it. So this led to more stars being born, But before that, these atoms grouped together over lots of time. Atoms came together to form stars and galaxies. So these atoms come together now to form stars and galaxies. You know, sometimes I will go outside and I'll just lie down and just look. And when you look, you see, can I see from here? No. You see one star right here, so then you see another star in close proximity to it. And then after that, now when you look, you just see a shooting star move up and say, no, that one they're active. That one they drink porridge this morning. And then after that, now you say, okay, and then the following night, you come back and say, okay, we look to see if you see your star. Because sometimes when I was growing up, I used to name them. I said, okay, see Johnny right here. So and when you look, you say, what's going on? They want to now come in place, right? Because of the movements. Because these galaxies are still stretching. So when you go to and pinpoint, yes, sir, go ahead.
So you know, I thought I was the only person who did that thing.
No, man, no, man, no. You see, I do some strange things, Mikey, that one of the strange things that I do when I ask my bachelor students, and they laugh just to this very day, when they did their final capstone project and they invited me, they laugh just gone. I say to them that to this very day, had I been outside, I'd turn on the camera and show you all of my bottles, my Arizona tin, my Dr. Pepper tin, all of those are in. I separate those from my garbage. No, it is best for me to separate it. You know, I don't care what the people then from NSWMA want to do with the gear out there. To them business. So if when we separate it, they want to go and clump all of them together, that's a for them business. But as an environmentalist, as someone who has studied the environment and has a great appreciation for the environment, I have to take care, I have to do my part. And my students laugh at this one and say, sir, you're wasting your energy. It's all right, let me waste it. Allow me to waste my energy because I want to know that when I come to a class and I'm speaking to you, I don't feel guilty to say that I threw my bottle in my other ways because I know the chemistry of it, that when them start to burn, that these toxic fumes in these plastic bottles are going to cause respiratory problems. Are going to cause respiratory problems. As we speak about the heat that cause these tiny particles to break off and upon cooling cause the clumping and the formation of stars and galaxies and you name it. Years ago, you know, a new development took place, and for those of you who can't go up to upper level, this is a possible question. Years ago, you know, in a newly developed residence housing scheme, they recognize that a section of the housing scheme, it no matter how them plant grass and plant flowers, them just brown. Nothing survive. Them no see lizard, them no see ants, earthworms worse. And at some point in time, they recognize a very toxic smell. So the man them say, here the plant. No man, something not going right. And the authorities came in and they surveyed the land and they said, well, you know, we recently built and we never saw anything. We don't know what is happening. And you know, the geologists came in and people from NWC came in and they said, well, we don't know what is happening. And they said, no man. And they did air quality sample. And the air quality sample suggests that a toxic gas is being produced to the point where it caused respiratory problems in the young and the old, you know, but more particularly the young people, kids, babies. It's when they start digging and they start digging and they start digging and they dug down, they found an old NWC chlorine cylinder. It was so old that they could say, whoa, this was from before my time. The old time cylinder, them time, you know. But it was empty. So they believe. Because then they explain what happens with gas particles. And this is why they say to you, do not throw your tins into the open fire. Do you understand why I have to separate my garbage now? That's the point I'm making. Because when you use your aerosol spray and you say, it done, so I throw it away. Me spraying and nothing now come out of it. When that is exposed to heat, those tiny particles, the whole business of Brownian motion comes into effect. Those tiny particles, when they are at rest, we say that they have potential energy. But when these tiny particles now are heated, they gain kinetic energy. And this kinetic energy now causes this rapid, haphazard movement. Now, when you look at these galaxies, when you look at these, the breakaway of these particles, the way they move fast, it will move fast and just bouncing or something. And when it bounces or something, sometimes I'll get stuck to the something and then no new form. This is what Brownian motion is. So what happened is that these, maybe the one little drop of chlorine that was inside of it, because it was very deep within and Earth became very hot, it expanded and pretty much filled that cylinder to the point now where it starts to bombard against the walls of the cylinder and it starts to push through the nozzle of the cylinder and the gas started to escape, killing all forms of animal and plants and started to kill the humans too. You see how science nice? When that was removed, the people didn't have them normal life. Science is nice. Science is nice. Same thing happened in galaxies. So the first stars created bigger atoms and group of atoms, right? It is saying that they led to more stars being born. More stars being born. And at the same time, galaxies were crashing and grouping together. And guess what? You see when them galaxies clash and group together, you have new stars being formed and new galaxies being formed. You know, when I go to some countries, I'm look up in the sky, me swear to me see more stars and them sitting there than when me there in Jamaica. Me not ask you. And there are some times when, you know, there's just a difference. There's just a difference. Some of them shine brighter than others do. Right? And one may say how translucent the atom is, right? We're not going, the course is not going to allow us to get into the whole cosmopolic, you know, stuff of why this happens, and you know, the physicists will tell you, and the chemists will tell you, and the biologists will. We're not getting that, but what we're doing is more surface, just to get an understanding as to what is happening. So as new stars are being born, you have some dying. Some going to die because the heat may destroy one or two of them. Then crashing into others may destroy one or two of them. And think about it. If you don't have some of them dying, you know what's going to happen? Maybe, in my view, maybe we're not going to have no nighttime, because when nighttime comes, the sky will bright up. Because those that are more translucent and can give off more light, they shine up in other place. All right? So we have things like asteroids and comets and planets and black holes that are being formed. Really for something. One may ask the question, sir, how long all of this took? We're going back to time scale now. They are estimating that the universe is about 13.8 billion years old. They're estimating that the Earth, that the universe rather, not just Earth, but the universe is about 13.8 billion years old. If you ask me, that is a very long time. Too long even. Too long. So this is how pretty much the universe began. Because it got so big and led to such great things, some people call it the Big Bang Theory. Right? So that's in essence what it is. Right? But it's something that continues to stretch. It stretches, and people believe that it is still stretching. And to be honest with you, I still do believe that it is still stretching. We have evidence. And remember, science is based on evidence. Remember, I use the analogy of that very fast dentist, and I'm very grateful for my dentist. And I mean, I tell them that when I go there We sit and we talk very candid. I say, if you never fast, you know, see this, you know, but I thank you. So that fast dentists use them device, the new technology, because dentists of the past never have them something else. And when things are going to happen bad, them say, here the plan. They have to take out the pliers and take it out, you know. You understand? And they don't do that anymore. They can do an extraction using anesthetics, you know, where you don't feel nothing, right? You don't feel a thing, all right? And when I was convinced, because of course, you know, the dentist can't, when am I out it, you know, go there. So it's when I was convinced, and she used 3 years of data to say, sir, look under something. It was one little dot 2 years ago. Last year, you see how much it grow? They say, look on the x-ray we just take a while ago. I said, well, I can't dispute the fact. You have given me the evidence. Doc says, based on the rapid growth of this that we are seeing, we have to go in there and get rid of it. I still have the tooth in my mouth, you know. They never take out the tooth, you know. The tooth is still there. But they had to go and do something in order to prevent, you know, it from the crack from going any further, because once it crack and get to the nerve, that would have been, I would have been in pain. To the point where the x-ray shows that it was like about a millimeter separating the crack or the fracture from the nerve. And it baffles my dentist to this day that I'm not in pain. And I said to her, I said, dentist, if I feel one iota of pain, trust me, your phone will be ringing off. They couldn't believe. They were baffled to see how close it was to the nerve, to the point where the x-ray wasn't able to show the stuff. And they said, why? How are you not in any pain? Because anybody who comes in with something like that, we're supposed to have to give them anesthetic and double dose and triple dose, because I said, I don't feel anything. If you didn't point it out to me, I would be ill. And then long after, I started reflecting. And then I said to myself, you know, say, even though them fast, them right. And then I started looking back and said, I remember every time I started flossing there, I used to have a gum bleed. Every time that I floss there, I used to have a gum bleed. So you know what I do now? Every time I floss and I have a gum bleed, it gives me, you know, some antennas go up to say, okay, am I having the same issue? From they have done the corrective measures and I floss that area, there is no more gum bleed. And I just couldn't make the correlation between the two. All right. So I'm saying to you, it may be very expensive now, but I know I started taking care of my oral health. Then I started working. And I'm going to encourage you to do the same. Remember, you know, we're talking about the sciences here. So the same thing the dentist does, and the same thing the physicists and the biologists and the chemists, is the same thing the astrologers and the geographers and the geologists are going to be doing. We're talking about evidence-based theory. And something we're just going to come out of the thing. All right? Now, here what is going to happen now. So pretty much that concludes in a nutshell what the Big Bang Theory is all about. All right? But of course, you can go and read a little bit more. I went into a little bit of the chemistry, and I talk about the atoms being formed and new compounds being formed and so forth. I'm not expecting you guys to go and read and get more information. I don't know. The question may come. Explain the Big Bang Theory. Compare it with catastrophism. Do you believe that catastrophism has an impact on the Big Bang Theory? That could be somebody's perception. It's how you argue the point and you say, yeah, you're wrong, you know, but your argument's so right. Never give the mark. Right? Because it is so subjective that, you know, one theorist is saying something and then you can have another theorist saying something else. All right, so let me ask a question. You have a more general view know of what the Big Bang Theory is all about? Well, that was a question.
Yes, sir.
Okay, thanks. Yeah,
Yes, we have an idea, sir.
You have an idea now. All right. Cool. Anybody else? What about Leonie? Karen?
Yes, sir.
You think it has struck a fuse that you can read more about it now to get more information about what this Big Bang Theory is all about? Talk to me. Somebody say yes. One of the things that I didn't get into is a cosmic microwave background resulting from the Big Bang Theory.
The radioactive period.
That's right. That's right. And one of the things that they're saying that we could all see it at one point in time, it was so evident for us at some point in time that we could see. And I'm saying to myself, but see how so? And then, I was reminded that when we had those big back television, the cathode ray oscilloscope one, the big back, not the flat screen one that all of us have now. All right. When you're moving and we're connected with our antenna or with a satellite, right? When we're moving from those analog channel from one channel to the next, and you saw that grainy something on the television, that is the cosmic microwave that they're talking about, right? So let me see if I can project a picture of it.
I'm sorry, it's the person from what you're teaching. Just a quick question. When you look in the sky and you see like some of the stars are blinking and some are still, like what's the difference?
You came in a little picture. When you look into the sky and see what?
When you look into the sky and you see like some of the stars, they are blinking and some are really still. What's the difference?
Aha. I think I made mention of it, a little piece of it just now. What do you think is happening? I want to hear from you guys. Let me hear what you're thinking.
All right, so sir, I think that what's happening when you see the stars blinking, two things could be a factor. One is that it has an arbitrary object that is going around it. So each time that object passes, it appears as a blink. And also it could be a dying star.
It could be.
I think it has to do with the gases in the star that gives off the different colors and stuff like that.
Different wavelengths.
Yeah.
I think so too. So what you just said a while ago, Henry Rodriguez, is what I alluded to before, Benica, where it is a formation of these. I will tell you what I said earlier. It is radiating some level of light. Okay, so it would have absorbed some of the light rays from earlier, and then now at night it is just reflecting some of these light rays. Some of the energy is coming off at night because it is somewhat cooler. So you see, great, thank you, Lord. Anybody knows those solar, they call it now, solar garden lamps, where you just put it on in the garden, and then in the sun it absorbs all of the sun rays, and then at night it just light up?
Not me, sir.
Yes, sir.
Yeah, man. So it's something like that. So you have some of these that are going to be absorbing the light, in the daytime, the energy from the sun, and trust me, that the sun they act. You take one aeroplane and you sit on the right hand side, That's why when we go for an airplane and we beg them, don't give me that side here. And especially when I'm going to a particular country, not a side here. Give me a search and we don't have anything. You say, okay, fine, I don't want the window. Because it's when you open the window there and you're flying beneath the clouds and that the sun is coming upon you, you stay burned. And when you move to the upper level, we talk about the different rays and skin cancer and what is and all these other things that can happen. So I believe that it is attracting some of the energy from the sun, and then it is just reflecting them afterwards, right? It could also be that the gas that is it's given off, or that it has trapped. Some of them are dying. So yes, the dying ones could be losing its life, and as a result of that, no, it fades, and then you don't see it's shining as much. So yes, it does happen, and that's a very good observation. We can look more on even the shooting star, Benito. Sir, why is it that we see the shooting star? The one that have enough energy, drink enough porridge in the morning. No, sorry, enough sugar and water, so when nighttime come, it can't sleep. So move up and down. Right? Good observation, though. Let me see if I can. How do I take this to you?
Oh, sir.
Yes, please, go ahead.
And the reason you give about the airplane that you don't want the window seat, you could just close the window.
I know, I can, but guess what? So even though you close the window, and the plane is insulated because of the rays that are coming in, it still pelts it. So I don't like the cold, but I prefer to be cold than to be hot, because when I'm cold, I have a cheaper method to warm up. So this is why the aircraft must have air conditioning inside of it to sort of combat the heat that is going on. And this is why sometimes they and especially not sometimes, especially when you go into these very far countries, like if flying from Houston to London, what time of day do they do these flights normally take place?
What type of what, sir?
Day or night. When you go into these far countries, day or night?
I wouldn't know.
What do you mean you wouldn't know?
I've never traveled, so I wouldn't know.
But we're on a trip. We're on a geology trip. We're on an environmental studies trip. When we reach year 4, by then COVID is supposed to dawn, and then we want no more vaccine, to take no more plane, and we're going to go up and we're going to look at some stuff. The truth of the matter is,
for real, sir.
Yeah, man, for real. Just make sure you get A's for the stuff, right? Forgive me, Lord. We can plan a trip. Provided that COVID. Huh?
Sorry, foot in the bill.
Go away, Asia. You're supposed to be my friend. Go away. Sorry, Mikey and Benico will put the bill for all of us. These flights, these long. Say it again, Benico.
I say you guys can just start praying from now. Pray for me.
Yeah, you so making us come back and say, I have this covered. These longer flights is not by chance that they put them at night. These longer flights, because it's cooler, they use less energy. All right. The sun rays up there is pelting. I went to a conference I think I went there like 3 times. San Diego, Anaheim, and San Francisco for back conferences. Very nice. California is huge. It's really, really, really very nice. And I leave from Jamaica on the 7 o'clock flight on American. I get to Miami by 7 o'clock Jamaica time, which is 8 o'clock for them time, 9:30 for them time, which is our 8:30. I'm in Miami, and I'm sitting in Miami sometimes for hours before we leave, if it's a direct flight from Miami to Cali. If I have a connecting flight, I may leave in the day to go to North Carolina or to Texas and then take the other flight there. But if it's a direct flight, best believe that I'm going to sit down at the airport for many, many hours until evening come. Then them have the night flight to go to California, even though California is like about 3 hours ahead of Florida for argument's sake. So you get there, you get to California at 12 o'clock. It is 9 o'clock in Florida, right? So you actually use less energy. So even though you close the screen, my friend Asia, it's still pelted through, man. Me not lie, it's still pelted through. The rays, and you can't even look into the rays because it's going to damage your eyes. Right? So, you know, you have some very nice people, you have some also very mean people. So, you know, once them rays come in, they have to close the blinds. They have to close it. And sometimes the pilot will come out and say, you know, those sitting on the right side of the plane, we're asking that to close the shade, and the flight attendants will come in and ask you to put it down. Serious stuff. I explained something earlier, and something happened in an experience I had in one of the flights. As I try to find this thing to show you that I need to tell you about. So when I am traveling, be very vigilant, you know, because if them say you're not supposed to carry one light up on the flight, I mean, see you have the lighter pushing on your shoes bottom. I don't care what you want to call me. Oh, hey, that one just put the lighter in shoes bottom, because if it's going to make the flight reach safe, fine. But if the flight attendant say, if you're going to put the lighter in and something that's going to explode, I mean, no, something can dead. If it explode, all if it now go dead upon explosion. But the mere fact that me look at the body of water beneath that aircraft that is going to drop in, me know me dead. It's like Master Scully who land that flight in the Hudson River. Me dead. Incidentally. The day when that flight was being landed in the Hudson River, I was very much at the airport, flying out. And my wife knew that there was an emergency landing, and she know how me stay, and she never tell me. Is when me ready for board the flight and me see where I go on, I call her and tell her to come pick me up. She said, I reach back at work. I said, I don't care, because there is no way you're going to catch me up on a plane here. I nearly had a case of peristaltic constriction that would have embarrassed myself. And it says me reach on that flight there, me drop asleep because I don't want to feel it, I don't want to hear it, I don't want to see it. And
Sir,
if you wake me up,
won't be that.
and if you wake me up and say, sir, the plane is going to crash, remember say, you not going to live to see it crash, because I'm going to have you for it. You understand? But so what happened is that we're coming back one year and this guy had a basketball. No, there was no air in the basketball there, so we believe, right? They kind of crush up and in the dream, but he had it in his hand luggage, and the flight attendant saw it and said, I'm sorry, but this cannot fly on the plane. It has to be shipped. And he was like, but I spent a lot of money for it. So me look funny, mommy. Me just want you to flight attendant say it can't go on the plane because me help her. So me sit down and look for him. She said it cannot go on, and she went to the back and hear up on the phone, the intercom, and she says the flight is not moving. There's a delay and so forth and so on. And she come to the guy and say, here the plan. If you don't comply by giving it to me so I can hand it to somebody at the gate, you will have to leave the flight. But I have to go back to school, then. Bossy, hear what the woman saying, no, it's either you or the ball. But it's not going to be us because I am implicated in this. So you got to listen. And I don't care. When we come to Jamaica, you beat me. But for now, I am thinking about my safety coming back on that flight. And then she explained, she said, listen to me. And it's true. It is exactly what I just explained to you. You may not see the air in the basketball, but as the plane gets higher, and the pressure falls, the balloon, not the balloon, the ball is going to start fill up now with air. The ball is going to get so light that it can now go and start bouncing in the aircraft violently, hitting out windows, so it is known that it now damages the air pressure in the aircraft, and that the aircraft can pretty much go down. No, we not sitting on nothing. And if you decide, say, him now come out, bust up, make me catch your other flight because I'm not staying here with him. And of course, you know, when people understand the significance and the importance of it, and the flight attendant was like, sir, you're holding up the flight and it's not going to be moving. And security people themselves come on the plane now. What have you been moved? Well, and this was like, I don't care. We didn't want to make that by one. Or you ship it. You should have put it in the barrel, say up on the water, right? So I'm saying to you, the chemistry, you have to understand the chemistry of it. You must understand the chemistry of this thing of sharing. Sorry. But yes, so the cosmic microwave background is a leftover radiation from the Big Bang. And it was formed really from the rapid inflation and expansion and cooling. And you see that inflation's word, that's where I want to go next, right? So let me just read what I have right here because it's not sharing. So it says the CMB, the cosmic microwave background, I will send you the document, I have it to send to you, is a leftover radiation from the Big Bang, or the time when the universe began. As the theory goes, when the universe was born, it underwent rapid inflation, similar to what happened with that basketball. Expansion and cooling. The universe is still expanding today, and the expansion rate differs. The expansion rate appears different depending on where you look. The CMB, which is a cosmic microwave background, represents the heat left over from the Big Bang. You can see the CMB with your naked eye, but it is everywhere in the universe. It is invisible. It is invisible to humans because it is so cold. All right, and it says that according to NASA, according to NASA, the CMB fills the universe, and in days before the cable television, every household with television could see the afterglow of the Big Bang. When you move it from one channel to the next, you see evidence. You know, you see that little, those of you are older enough, you see you see that, you know, black screen with the little flashing stuff coming on until you can find the other signal, or sometimes you have to beat the TV from the back in order for it to get some good signal. You know, all of you are young people, so you have the remote.
Fix the antenna.
That just dated you, Paz.
Yes, sir. You have to beat it.
Yeah, man, you have to beat the back of the TV so you come on. So you see that little black sort of looking stuff? That is an evidence of the cosmic microwave. All right, so I'm going to send you the
black and white TV too.
The black and white TV, yeah man. So I'm going to send you this document that I'm looking at. It puts a lot of things into perspective. So I've got a nice picture of this one here. Can I take a picture of this on my phone and put it in Google? A nice picture of what the after effect of the stuff. Let's see if I can. And the after effect of this, and then I can I will send a document to you so that you can have a look, a read on your own, because of course you need to read it. Okay, I just see a message files. Picture. Let's hope it comes out. So Mikey just said black and white TV. All right, look into the group, you'll see. Mikey just said black and white TV. This is a color TV version. That's a color TV version. So back then with the black and white television, you would have this sort of smearing of black and white. This one is a color TV version, where it is that you see different colors. So it comes back to your point, your question, Benito, that Some of them are, remember, you're talking about atoms, elements are being formed, and some of the elements are colored. Some of the elements radiate, you know, light waves. So you'll see some shining brighter than others. Right? All right. Okay. So as I said before, there's so much more to read about the Big Bang Theory, and I have two handouts here that I'm gonna send out to you at the end of class that you can read through. And there's this one here in particular. They have different linkage. The hyperlink inside of it, when you click on the hyperlink, it takes you to another document. Sorry, that gives you even more explanation as to what is happening. Now, is outside of the Big Bang, there are two other issues. There are two other issues. One, inflation. Two, creationism. When we talk about the universe, we're talking about creationism, and we're talking about inflation. I'm going to do creationism a little, last. Pretty much, the inflationism is really talking about what has happened. When you look at, for example, the steady state theory, it says that in cosmology, a view that the universe is always expanding, but maintaining a constant average density, with matter being continuously created to form new stars and galaxies at the same rate as old ones become unobservable, and as a consequence of the increase in distance and velocity of recession, right? We can look at the difference between the Big Bang theory and the steady state theory. So we can look at the steady state theory. We can also look at inflation, and we can look at the creationist, right? So the inflation really is really saying that, you know, as it says, people have been bashing the cosmic creation, lumping it together with strings, multiverses, which inflation has helped to popularize, and other speculative propositions from theorists, and, you know, talking about in some aspect supporting the Big Bang theory, right? So they're saying they proposed more than 30 years ago. Inflation holds that an instant of 10 times 10 to the negative 43 seconds, according to one estimate, after the Big Bang theory, gravity flipped inside out, briefly becoming a repulsive rather than an attractive force. And as a result of this, the cosmos underwent an almost unimaginable rapid growth spurt, which has a profound impact on its evolution, right? And this is what they're talking about to be inflation. I'm going to ask you to look at it. Sir Lindy is going to be one of the godfathers in all of this. This document that I have here is going to put a whole lot of things into perspective. A whole lot of things into perspective. So I'm going to give you an opportunity to read this first before I get into the nitty-gritty of this. But I want to also mention, because I also want you to read it. Oh boy, to give me your feedback on this matter. A few weeks ago, I said to you that my paleontologist lecturer and I had a little walk-in, because he was talking about the whole business of creationism, and, you know, as a Christian, I had some issues, and I just did what I was supposed to do in order to get what I was supposed to get, and paleontology was one of my highest grades I got in my understudy work. In a nutshell, creationism is the belief that the universe and the various forms of life were created by God out of nothing. And that's what the Bible talks about, right? What it is now that they're saying that it explains diversity of life as a recourse to the doctrine of God or some other divine power. What creationism is talking about is, did God see or put into play all of this that we're talking about, the cosmic realms of stuff, the stars and the galaxies, and if all of those things were in place, because it was theorized from the Big Bang Theory that everything started off with a spot. So if it started off with a spot, creationism now is saying that, was God part of the expanse of what it is that we are seeing now with stars and galaxies and all of them wonderful stuff, right? A very uncomfortable area for those of us that are believers. And this is why I have some people who will talk about the business of evolution, to say that some people say that God did not have a part to play in this aspect. Try as I may, when I was studying it and I was trying to get my point across, I was outnumbered, and I said to myself, I cannot win. So let me just be malleable enough to hear the viewpoint of another thing. So I'm going to send you this document. I want you to read it. I have gone through the Big Bang Theory. I'm going to send you the document on inflation. I'm going to send you the document on creationism. And I want you to read it, because in the whole creationism, it even quote passage, Genesis 1:24, right? It says both types of creationists, however, believe that changes in organisms may involve changes with the species, often understood as a kind mentioned in Genesis 1:24, or downward changes such as negative mutation, but they do not believe that these changes can lead to the evolution of a lower or simpler species into a higher or more complex species. Thus, the theory of biological evolution is disputed by all creationists. When you read it, it opens, a whole can of worms, and that's why sometimes when you this point, and I'm going to end it on, well, I'm going to end it. We have one other thing to say. When I was preparing for class today, as I said today, I spent the whole day just preparing for class. When I was preparing for class tonight, I read it and I said to myself, I started to reflect, sat down outside and just started to reflect. And I said, that's why you have some of these scientists who believe that it starts with them and there is no God, because there are so many unanswered questions that, it brings into question one's spiritual belief. So I am not here to put anything down your throats. No, I am here to present to you the information. You're going to read it and you're going to come back to me, so it is that we can have a fulsome conversation of what it is that we're having. And this will have on Wednesday. We won't spend the whole time on Wednesday on it, because I've gone through the Big Bang, and we're just going to be looking at these two other aspects of it. I'm going to send you the document now, because I want to give you an opportunity to start reading from tonight into tomorrow in preparation for a class on Wednesday. It makes good reading. Don't think that it's all doom. It makes very good reading, and it puts a lot of things into perspective. All right? And the last thing that I want to say to you is, at the start of the class, I really got upset with some of you, to the point where I just fling a few of you in the waiting room, and then you guys came and joined my class. It is unfortunate that I come to class and I'm asking questions, and a few of you, well, not a few, quite a number of you are not reading on your own. And I'm going to speak to Mr. Waldo, I'm going to speak to Ms. Dunbar, I'm going to speak to Ms. Williams, just to get a feel of the class, to see how it is that you were handling the other courses, right? Because it ends here. You're going to come to my class, you can read, so we can have a conversation, we can answer the question, and we can debate about the matters, all right? So I forgive you for tonight, and I'm going to start afresh for Wednesday. Any questions?
Not from me, sir.
All right, thank you, sir. All right, so I'm going to just have me a cup of tea, and then I'm going to fix up this thing. I'm going to send it over WhatsApp. I'm going to send it over WhatsApp so that you can see. I'm sending it over WhatsApp. So those of you who are not in the WhatsApp group, please ensure that you're in the WhatsApp group, or communication really is in WhatsApp. I want to know that you guys have it. Let it go into your junk and you say, sir, I didn't see it. I can check to see that you have read or accessed the information easily on WhatsApp. That's why I use it. All right, guys. Thanks for coming out. I enjoyed myself today. Let's see what will happen come Wednesday when you read and you are going to come and talk to me about the whole business of creationism and inflation as it relates to the Big Bang Theory. Have a good one.
All right, sir. Same to you. Wednesday.
Same to you, sir.
Same to you, sir.
Come on.